Hi students, welcome to Diamond Group of Institutions NEET and K-CET online classes. Okay, today we are going to discuss about the gravitation chapter. Okay, so from this gravitation chapter we can expect one or two questions in NEET. So concentrate, actually gravitation also totally formula based chapter only. Okay, so now see the first question. 4 point masses each of mass m kept at the vertices of a square of side A. So 4 masses are there kept at the vertices of the square, and each side is the A, side of the square is the A. Then the potential energy of the system, potential energy we have to find. Okay, na? So to find the potential energy, first how many pairs possible, that we have to find. So now here how many masses are there? 1, 2, 3, 4. 4 masses are there. So to find the number of pairs, we have the formula number of pairs equal to n into n minus 1 by 2. So 4 masses are, n means the number of masses. 4 masses are there. So 4 into 4 minus 1 by 2 equal to the 6 we will get. That means 6 pairs possible. So here to here 1 pair, here to here 1 pair, here to here 1 more pair, here to here 1 more pair. 4 pairs completed. And next so from here to here 1 pair, and from here to here 1 pair. So total 6 pairs. So we have to find the total potential due to this 6 pairs. Potential energy formula already we know, U equal to the minus G m1 m2 by R. Okay, so U equal to minus G m1 m2 by R. So potential then minus G m by R, that is. Okay, na? So either U equal to minus G m1 m2 by R. So use this formula and find the potential energy between the masses, particles. Okay, now the potential energy between these two particles and between these two particles, between these two particles is same. Why? Because all the masses are same and the distance between all the particles also same. Here to here distance A, here to here distance A, here to here distance A, here to here also distance A. So all the mass is same, the distance between the mass particles also same. So potential energy between these two and potential these two is the same. So I am writing here 4 into 4 pairs are there na? So 4 into potential energy. So now potential energy between these two minus G into m1 m2, m into m square by distance between these two A. So minus G m square by R. So minus G m square by R plus my distance between these two A, minus G m square by R. So these 4 sets are same na, this time multiplying by the 4. So U equal to minus 4 into G m square by R. 4 pairs ka potential energy completed. Next the potential energy between these two pairs. Here also masses are same and the distance between these two, this is the length A, means this is also length, side is A, means what is the length of this one, means root 2A, from the Pythagoras rule, right angle triangle. So this length also root 2A. So this mass, these two masses mm only, here also masses are mm only, distance between these two also. So 2 pairs we are getting. So potential energy of the 2 pairs also same. I am writing 2 into potential energy between these two minus G m1 m2, m into m square, G m square by distance between these two root 2A. This is the G m square by root 2A. So how many pairs are there here? Same 2 pairs are there, minus 2 pairs are 2 into I am writing. So potential energy between the 4 pairs is 4 into G m square by A. Between these 2 pairs is nothing but the 2 into G m square by root 2A. If the masses are different, then we will get the different values. Okay, na? No need to multiply. That time we don't multiply 4 and 2 here. If masses are different, we will get the different remaining row. One more problem I explained based on that also. So now see here we got minus 4 Gm square by A plus into minus Gm square by root 2A. From these two terms I am taking the common as Gm square by A, minus Gm square by A I am taking the common. So minus Gm square by A, in this case what is there? 4, and here 2 by root 2. So minus into plus minus, we will get minus into plus minus only, same thing we will get. Minus Gm square by A into 4 plus 2 by root 2 we can write. 2 we can write as root 2 into root 2. So root 2 will be root 2. So now potential energy of this system is minus Gm square by A into 4 plus root 2. B is the right option. Okay. Now come to see the next question. Consider two configurations of a system of 3 particles How many particles are here? 3 particles. This system, they only given these diagrams. Masses m, 2m and 3m, they arrange like this: m, 2m, 3m, m, 2m, 3m. Okay. The work done by external agent in changing the configuration of the system from figure 1 to figure 2. So configuration changed. Initially the distance between the distance between the particles is a only. Now the agent did some work and the distance between the particles changed to the 2a. So then what is the work done by the external agent we have to find. Okay, so what is the work done by the external agent? Already in previous yesterday class we discussed that. So sum of all the works equal to the change in the kinetic energy we discussed. That means work done by the agent plus work done by the conservative forces plus work done by the non-conservative forces equal to the change in the kinetic energy. Okay, this formula already we know. Okay, na? So how much work done by the agent we have to find. So here the energy due to this potential energy, by changing its configuration, energy will be stored in the form of the potential energy. That means here that is a conservative work done by the conservative forces. Here this one we have. Non-conservative, no, we don't have. And here these particles are not in the motion, we don't have any kinetic energy. So from this what will we get? Work done by the agent equal to the minus of work done by the conservative forces. That means this work done is in the form of the potential energy, electrostatic potential energy or gravitational potential energy. Okay, na? So here in the form of the gravitational potential energy here. So now work done by the agent equal to minus work done by the conservative forces. Now first work done by the conservative forces also we know work done by the conservative forces equal to the minus del u, change in the potential energy. Okay, work done by the conservative forces equal to the minus del u, so change in the potential energy. Okay, so now work done by agent equal to the, we can write it as work done by the agent equal to the minus wc na. So wc equal to minus del u. At the place of wc write down the minus del u, minus a minus plus, so we will get the del u. That means work done by the external agent is equal to the change in the potential energy. Okay, na? Work done by the external agent is equal to the change in the potential energy. We have to find the change in the potential energy. So now see the first configuration. How many mass particles are there? 3 particles are there. How many pairs will form? N into n minus 1 by 2. 3 into 3 minus 1 by 2. We will get the 3 pairs. Okay, 3 pairs. Here the masses are not same. Okay, so now potential energy equal to the minus G into M1 M2 by R. M1 means to M, M2 means to 2M. M into 2M, 2M square by R means to A. Between these two potential energy minus G 2M into 3M, 6M square by distance between them A, minus between these two G into M into 3M, 3M square by distance between them A. Okay, now here minus gm square by a is the common, then remaining terms here 2, here 6, here 3, 2 plus 6 plus 3, then we will get the initial potential energy is minus 11 gm square by a. Now configuration change it to the, that means the distance between the particles change it to the 2a. Now final potential energy I am going to find. Final potential energy between these two, okay, minus g into m into 2m, 2m square by distance is how much? 2a plus minus between these two, okay, minus g into 2m into 3m, 6m square by distance how much? 2a. And next between these two, minus g into m into 3m, 3m square by distance between these two, 2a. Okay, from here again same, take the minus g m square by 2a common, then again we will get 2 plus 6 plus 3, same in the previous how we did. So like this we have to do, we will get the minus 11 g m square by 2a. Okay, initial potential energy is minus 11 gm square by a, final potential energy is minus 11 gm square by 2a. Okay, na? Okay, then we have to find the work done by the external agent. Work done by the external agent equal to the change in the potential energy. Change in the potential energy nothing but final potential energy minus initial potential energy. Final potential energy is how much? Minus 11 gm square by 2a, minus 11 gm square by 2a, and minus initial potential energy is minus 11 gm square by a, minus of minus plus, we will get plus 11 gm square by a. So now simplify it, here 11 gm square by a is a common, so from this term we will get the minus 1 by 2, from this one we will get the 1, minus 1 by 2 plus 1 is nothing but the plus half, so 11 gm square by a into half means we will get 11 gm square by 2a. So 11 gm square by 2a, C option. Okay, if they give the masses, equal distance, then follow this one. If they give the unequal masses, follow this one. If they ask the work done, so remember this formula, from this what we are getting. Okay, next problem, see now, a person brings a mass of 2 kg from the A to B. He is bringing some mass 2 kg from one place to the other place. The increase in the kinetic energy of the mass is, okay, mass they given, mass equal to the 2 kg they given, and next increase in the kinetic energy given, that means change in the kinetic energy 4 joules given. The work done by the person and the mass is minus 10 joule. Okay, either minus 10 joule means the work will be, some energy will be lost due to the non-conservative forces. So now this work done is due to the non-conservative forces. Okay, that work done equal to the non-conservative forces equal to the minus 10 joules. Okay, so now here already we know about the agent, nothing they mention, so that's why I am not considering here agent work done. So work done by the conservative forces plus work done by the non-conservative forces equal to the change in the kinetic energy. Already we saw here formula. Okay, so here work done by the conservative, what are they asking? They are asking the then VB minus VA. VB minus VA means so change in the potential. Okay, now change in the potential they are asking. To find the change in the potential, first we have to find the change in the potential energy. Okay, now we know the relationship between the potential energy and the potential. That's why first we have to find the potential energy from the given data. After that find the potential. Okay, now see conservative work done by the conservative forces equal to plus non-conservative forces ka value they given minus 10 equal to change in the kinetic energy given 4 joule increase. Now conservative ki work done by the conservative forces minus 10 cent, that side 14 joules. Now conservative forces ka value already we know, work done by the conservative forces equal to minus del U, already I said here also. So minus del U I am writing here, so 14 joules minus into del U means change in the potential energy. Change in the potential energy equal to the final potential energy minus initial potential energy. The body is moved from the A to B, final is the B, initial is the A. So final potential at the B minus potential energy at the initial at the A. So equal to 14 joule. So now minus I am sending this side, it will become minus 14. Okay, and next to UB minus EA, potential energy ki and potential ki relationship. Potential energy equal to the mass into potential at that point. Okay, now so U equal to M into V. So now potential at the B point is M into VB minus potential at the A point is M into V. That means potential energy and potential ka relationship is this one. From this I am writing forming the potential in the from the potential energy I am writing the potential. So M into VB minus M into VA. Mass is the same here. I am taking the M as a common, VB minus VA. So now I want VB minus VA, potential between the VB and VA. So VB minus VA equal minus 14 by 2. So we will get the minus 7 joule per kg. So potential difference between the B and A is minus 7 joule per kg. D option is the right answer. See the sign properly. Why? Because either 7 joule per kg is there, minus 7 per joule. We will get the answer, but sign is the important. So work done by the conservative forces equal to the minus del U, change in the potential energy, minus del U. Okay, na? Del U is nothing but the final potential energy minus initial potential energy, and the relationship between the potential energy and the potential is nothing but U equal to the mass into V. Okay, no? So there also in the electrostatics also we have work done equal to Q into V. Q place में here mass, they have charge here mass. Like this we have to solve the problems. Next question, the mass of the moon equal to 1/81th mass of the earth. Okay, mass of the moon and mass of the earth ka relationship given. Mass of the moon equal to the 1/81 of the mass of the earth, I written here. Next, the radius of the moon equal to the 1/4th radius of the earth. So radius of the moon equal to the 1/4th radius of the earth. Okay, I written here. What is the approximate value of escape velocity for a body on the surface of the moon? Escape velocity on the surface of the moon we have to find. If the escape velocity for Earth is 11.2 meter per second, escape velocity on the Earth given, how much escape velocity on the Earth is 11.2 meter per second, escape velocity on the Moon, how much they are asking. Don't get confusion here, whatever the data given, based on that we have to do. Actually the escape velocity on the Earth is 11.2 kilometer per second, but here they given meter per second. Don't get confusion here, whatever the data given, based on that we have to do the problem. Okay, now they are asking the escape velocity on the Moon. Escape velocity formula we know already. Escape velocity equal to the square root of 2gm by r. Okay, now so g is the universal gravitational constant already you know. M is nothing but the mass of the planet. If it is Earth, Earth ka mass, and if it is Moon, Moon ka mass, and r is the radius of that planet. Okay, so now here 2 is the constant, g is the constant. The relationship between the escape velocity and the mass and radius is v is directly proportional to the square root of m by r. Okay, now we have to find the escape velocity on the Moon. So escape velocity on the Earth by escape velocity of the Moon equal to the, so escape velocity is directly proportional to the mass of the planet. So Earth by Moon is there na, so directly proportional na, mass by Earth mass by Moon mass. And the next escape velocity is inversely proportional to the r, radius. So either Earth by Moon is there, here we will get the Moon by Earth, radius of the Moon by radius of the Earth, and the square root is there as it is. So escape velocity on the Earth they given 11.2 meter per second, 11.2 by escape velocity on the Moon we have to find equal to the me by mm, mass of the Earth by mass of the Moon. Mass of the Earth either mass of the Moon. Send this one to this side, 81 will go that side. So the me by mm value will become 81. Okay, na mass of the Earth by mass of the Moon will become 81, and radius of the Moon to the radius of the Earth, radius of Moon equal to 1 by 4 of the radius of Earth. Radius of Earth, send this side, rm by re we will get the 1 by 4 value, that is 1 by 4. Okay, na? So now we have the square root of 81 into 1 by 4, that means 81 by 4. Square root of 81 value is 9, square root of 4 is value is 2. Okay, escape velocity on the Moon we have to find equal to the, this one send this side. So 9 by 2 will become 2 by 9. So 11.2 into 2 by 9, approximately we will get the 2.5 meter per second. They are asking approximate value only. The escape velocity on the Moon is 2.5 meter per second. Remember the formula, escape velocity formula is square root of 2gm by r. Okay, see the next problem. A high jumper can jump 2 meter on the Earth. On Earth how much he can jump? 2 meters. With the same effort, how much will be the able to jump? That means with how much energy he is jumping, with the same effort, same energy he is jumping on the other planet whose density is 1/3 and whose radius 1/4 those of the Earth. Okay, so the planet ka radius is 1/3 of the Earth radius, and planet ka planet ka radius is 1/4 of the Earth radius, and planet ka density is 1/3 of the Earth density. Okay, whatever the given data I am writing here, planet density equal to the 1/3 of the Earth density, and planet radius equal to the 1/4 of the Earth radius. This is the given data, and they are asking the how much height he will jump on the planet. Okay, so same effort they are having, so jumping means the potential energy increases. So now same whatever the potential energy used on the planet Earth, same potential energy using on the planet Earth, same effort they given. So potential energy on the planet equal to the potential energy on the Earth. So he is jumping. So potential energy formula already we know, mgh. Mass does not change, it is a constant. It does not depend on the location or planet to planet, everywhere the value is the constant, already we know. mgh, potential energy formula is mgh. So potential energy on the planet equal to mass and gravity on the planet, and height he can jump on the planet equal to, these are also mass and gravity on the Earth, and height he can jump on the Earth. Okay, na? So equated, mm will be cancelled, we will get hp equal to the height, how much height he can jump on the planet, that we have to find. Hp equal to gp, send this side, so mm will be cancelled, ge by gp into he we will get. So ge, gp, so the gravity values we don't know, but they given the interior density and radius. So we have to write down the gravity in terms of the density and radius. So already we know gravity formula, acceleration due to gravity formula, g equal to gm by r square. Remember that formula. Okay, so from here g equal to g into this mass I am writing in terms of the density. Okay, we know already density equal to mass per volume, mass equal to density into volume, density into, so we consider the planets in the spherical shape only, so volume of the sphere is nothing but the 4 by 3 pi r cube. So in the denominator we have the r square. Now g into density into 4 by 3 pi into r square, r cube is there, r square will be cancelled, 1 r will be there. Now what is the relationship between the acceleration due to gravity and the density and the radius? Means acceleration due to gravity is directly proportional to the density of that planet and radius of that planet. Okay, now so now here see, now come to see this one, here we have the ratio ge by gp. So density gravity on the earth to the gravity on the planet. Gravity is directly proportional to the density of that planet and the radius of that planet. Upper numerator में we have the earth का density, earth का radius, by the denominator we have the planet का gravity. So planet का gravity directly density and so density of the planet by radius of the planet into height you can jump on the earth. So now already we got the rho e by rho p, density of earth to the density of the planet, density of earth to the density of planet, but planet stand this side, 3 will go this side, so density of earth by density of planet will get 3. re by rp, radius of the earth to the radius of the planet, radius of earth to radius of planet stand this side, 4 will go this side, so the 4. he, how much height you can jump on the earth? 2 meters, multiply you will get the height you can jump on the, with the same effort to how much height you can jump on the planet means, so 24 meters you can jump. D option is the right answer. Next, come to see the next question. A planet, one planet is revolving around the sun in an elliptical orbit. The linear speed of the planet will be maximum at. Where the linear speed is maximum, we have to find. From the Kepler's law, we can say that if a planet is revolving in the elliptical path, then angular momentum is conserved, or angular momentum equal to the constant. Remember that one. So here they are asking the linear speed. So we have to write down the angular momentum in terms of the linear speed. Already we know angular momentum formula, linear momentum into radius, which radius it is revolving. So mb into r equal to constant. Mass everywhere same, it should not change, but velocity, and if the distance changes from the sun, the velocity of the, or speed of the planet also changes. The relationship between the speed, linear speed, and the distance from the sun is nothing but the inverse proportion. Speed is inversely proportional to the r. Okay, now see here, a, b, c, d, these are the locations given from locations. So at what location the velocity, speed, linear speed of the planet is maximum. So that means speed is inversely proportional to r. V is maximum means r should be minimum. The distance from the planet to the sun should be minimum. So in these 3 locations, which path is the minimum? So from here to here, this is the maximum only, here also maximum, this is also maximum. So this distance is the minimum. So minimum distance, maximum velocity, maximum speed. So if the planet is at the A location, the distance between the A and the sun is, planet and the sun is the minimum, then the speed of the planet at the A location is maximum. Okay, compare with the remaining locations. So where the speed of the planet is maximum? At A. So A where is there? The C option. See the options also. A means here don't take the A. Okay, C option is the right answer. Like this you have to solve the problems. Next question, 7th one. A geostationary satellite. Okay, geostationary satellite means actually the earth will move west to the east. Okay, so geostationary satellite also move from west to the east, and to complete one revolution, earth will take the 24 hours. Geostationary satellite also will take the same time. Okay, not 24 hours only. Okay, remember that point about the geostationary satellite. What is the time period for the geostationary satellite? Means 24 hours. Okay, so the earth at a height of 6 r above the surface of the earth. Okay, this geostationary satellite is revolving at 6 r, at the height of 6 r above the surface of the earth. From the surface, suppose this is the earth now, radius of the earth is the r. From the surface at 6 r, at the height of 6 r, this geostationary satellite is revolving. First case. And next, what is the where r is the radius? What is the time period of another satellite? What is that satellite? Not mentioned. Another satellite orbiting at a height of 2.5 r from the surface of the earth. Okay, this is the earth now, radius of the earth is r. From the surface, one more satellite is revolving at the height of 2.5 r. This 2.5 r is from the surface of the earth. This 6 r is from the surface of the earth, not from the center. Okay, so for this geostationary satellite, time period equal to 24 hours. But what is the time period of this orbiter? We have to find. Okay, already we know from the Kepler's law the relationship between the time period and the distance. Okay, na? So radius otherwise. So t square is directly proportional to the r cube. T is the time period, r is the distance of the satellite from the center of the earth. Okay, na? So now first consider the geostationary. Geostationary ka time period T1 equal to 24 hours and radius equal to, radius means from the center to the satellite tak. Okay, na? So from center to here r. Okay, na? Radius of the earth is r and it is at the height of 6r from the surface. So total from here to here it is nothing but r plus 6r, 7r. Okay, na? R1 equal to 7r and for geostationary satellite time period equal to the 24 hours. Now come to the second satellite. So second satellite ka time period we have to find T2 equal to how much and the distance from the center of the earth. So this is the r, radius of the earth is r and the satellite at the 2.5 r from the surface. Now total is nothing but the 2.5 r plus r, 3.5 r. Okay, using the relationship t square is directly proportional to the r cube. T2 by T1 whole square equal to r2 by r1 whole cube. Already we can get it very easily. T2 value we have to find, T1 value is a 24 hours, r2 value is a 3.5 r, r1 value is a 7r. Substitute and simplify it. T2 by 24 r whole square equal to 3.5 1 so 3.5 2 so 7 we will get. 1 by 2 whole cube means 1 by 8 we will get. Send the square to this side, square root it will become, that means square root of 1 by 8. So square root of 1 is 1, square root of 8 we will get here. T2 equal to 24 by root 8. To do easily we can write 24, we can write it as 3 into 8. 8 we can write it as root 8 into root 8. Into 3 by root 8 is there, 1 root 8 will be cancelled, 3 root 8 we will get. Okay, now simplification do it fast. Okay, 3 root 8 ka value almost equal to 8.48 hours. So now 8.48 hours is the right answer. Like this you have to solve the problem. Now come to see the next question. The earth is assumed to be a sphere of radius r. A sphere of radius is r. Rotating about its axis with an angular speed omega. It is rotating with the angular speed is omega. If the effective acceleration due to gravity at a certain latitude, the given effective acceleration is lambda is gp minus 3 by 4 omega square r. At some latitude they given this value where gp is the acceleration due to gravity at the poles, gp is the acceleration due to gravity, then the value of lambda is, latitude we have to find. Already we know the formula, the effective acceleration, if the what is this one, the earth is rotating with the angular speed is omega, then at a particular latitude, at a certain latitude, to find the effective acceleration due to gravity, the formula is g dash equal to the gp minus omega square r cos square lambda. Okay, na? So this gp is nothing but the acceleration due to gravity at the pole. So that means from here we can get it very easily. If the at the equator, what is the gravity means? At the equator angle is nothing but the latitude is nothing but the 0. That means here this is the earth and this is the equatorial line and this is the polar axis. Okay, now at the equator the angle made by the position with respect to the equator is nothing but the latitude. Now if it is at the equator, then latitude lambda equal to we will get 0. Okay, if you substitute the 0 here, cos 0 value 1, so gp minus omega square. That means at the equator the acceleration due to gravity value is minimum. Okay, so at the polar axis, at the pole, so from here to here it is angle equal to the 90 degrees. Okay, now so now lambda equal to 90 degrees. If lambda equal to 90 degrees, cos 90 is 0, this term will become 0, then d dash equal to the gp. That means it is equal to the acceleration due to maximum at the poles and minimum at the equator. From this formula we will get. So actual formula is this one, but at certain latitude in the question they given g dash value is gp minus 3 by 4 omega square r. Okay, equate these two, compare these two equation. So gp is there, omega square r is cos square lambda plus we have the 3 by 4. So cos square lambda equal to 3 by 4, cos lambda equal to square root of 3 by 4, root 3 by 2 we will get. So in cos term when will we get the root 3 by 2 means 30 degrees. So lambda equal to 30 degrees. That means at the latitude 30 degrees we have this value. Okay, B option is the right answer. Next question. Ninth question, a body is projected horizontally from the surface of the earth, radius r, with a velocity equal to n times the escape velocity, neglect rotational effects of the earth, the minimum height attained by the body from the earth's surface is r by 2, then n must be equal to, n value we have to find, that means the velocity of the, here see, from the surface of the earth with the velocity equal to n times the, it is projected with the velocity v, that is equal to the n times to the escape velocity. Okay, na? The body is projected with velocity v, that is equal to the n times to the escape velocity, that is given, and the maximum height attained by the body is, maximum height attained by the body equal to the r by 2. Okay, na? Maximum height also they given r by 2. Okay, then what is the n value? This n value we have to find. So suppose here we are projecting one object, so at maximum height the velocity will become 0, at maximum height velocity will become 0. It is projected with some initial velocity. Whenever it is on the surface, it has the two energies. It has the velocity na, so kinetic energy. On the surface it has the surface na, potential energy. So initially it has the potential energy and kinetic energy, and the next whenever it reaches to the maximum height velocity will become 0 and it has only potential energy. That means if we write here, so kinetic energy equal to half mv square, potential energy here is minus g capital M by r, equal to the final, the velocity will become 0, kinetic energy is 0, and final potential energy equal to minus g capital M into r. R is nothing but the r plus this h, r plus h, capital R plus h, this is capital R. Okay, so after simplification of this one, v is nothing but v, they given n into ve. Okay, we have to substitute v plus my n into ve. Escape velocity formula we have square root of 2gm by r. All substitute that one, simplify that one, we will get the formula. Direct formula I am giving you, remember this formula. If you remember this formula, enough. H equal to n square by 1 minus n square into re. H is the maximum height attained by the body, equal to n square by 1 minus n square into re is the radius of the earth. N is nothing but the relationship between the velocity of the body to the escape velocity. Okay, na? Velocity equal to n into v, they given already. Otherwise n is nothing but the velocity of the body projected equal to the n times to the escape velocity. The n will give the relationship between the projected velocity and escape velocity. Okay, n will give the velocity of the projected velocity and escape velocity relationship they given. So from here h max they given r by 2. So h max equal to r by 2, n square by 1 minus n square, radius of the earth they given r. Okay, r will be cancelled. N square by 1 minus n square equal to 1 by 2 we will get. So cross multiplication, 2n square equal to 1 minus n square, minus n square, send this side, 3n square equal to 1, n square equal to 1 by 3, n equal to 1 by root 3. What is the relation? What is the n value? N value equal to 1 by root 3. C is the right option. Very easily we can solve. If we go through this one, it will take the more time. If we go through this one, it will take the 30 seconds only. Okay, follow this one. Next, the minimum energy required to launch a mkg satellite from the earth's surface in a circular orbit at an altitude 2r. Altitude 2r. Height from the earth's surface is 2r. Okay, where r is the radius of the earth. R is the radius of the earth. So first, initially it is on the surface. Now what are the energies we have to find? Initially on the surface, so total energy equal to kinetic energy plus potential energy. So initially it is on the rest, so it does not have any kinetic energy. So potential energy formula already we know, minus gmm by r. R is the radius of the earth. So whenever it is on the surface, the energy of the body is minus 2 gmm by r. Okay, now it shifted to the one orbit, some energy given to that body, and it is revolving in some orbit. Okay, it is in the orbital. Okay, so then what is the total energy whenever it is in the orbit? Okay, so total energy in the orbit is at some height from the earth's surface, so it has a potential energy, and it is revolving in the orbit, so it has a kinetic energy. So total energy equal to the sum of the kinetic energy and potential energy. Now I am going to write, so total energy equal to, in orbital code, Ke, kinetic energy equal of m v square. Either v is nothing but it is moving in the orbit, so orbital velocity, so m v naught square minus potential energy. Potential energy minus na, so plus into minus minus gmm by r. R small r I am writing. What is the smaller also I will tell you, just read that. So half m into orbital velocity formula. Remember orbital velocity ka formula is square root of gm by r. Escape velocity is square root of 2gm by r. Remember that formula. So half m square root, square is there, square root will be cancelled. We will get the gm by r minus same term I am writing here. So now next here small r I am writing now. This small r is nothing but the distance of the orbit from the center of the earth. Okay na? So from center of the earth, what is the distance we have to find? This is nothing but the r plus 2 r, 3r. So small r equal to the 3r here. Already I did here. Small r equal to the 3r. Okay, substitute at place of small r, 3r. So now here gmm by 2 into r plus में 3r minus gmm by r plus में 3r. So either gmm by 3r I am taking the common, then here we have the 1 by 2, here we have the minus 1. Then after simplification we are getting minus gmm by 6r. Okay, whenever it is in the orbit it has the energy this much, and whenever it is on the surface this has the gmm by r, then energy, minimum energy required to launch the mkg satellite means the difference in these two energies we have to do. So changing the energy equal to the final energy minus initial energy. Final is nothing but the orbital energy, initial is nothing but the energy on the surface. So orbital energy minus surface. Orbital how much we got? Minus gmm by 6r minus gmm by 6r. Here surface में minus gmm by r, इधर minus is there, minus into minus plus we will get gmm by r. So do the simplification. So from this what I am going to do, gmm by r I am taking the common, then first term में minus 1 by 6 is there, second term में plus 1 is there. After simplification we are getting 5 by 6 gmm by r, but options में that is not there. We have to simplify small g terms there, we have to simplify this in terms of the small g. So del E equal to how much we got? 5 by 6 capital G mm by r. Okay, so already we know the acceleration due to gravity, g value equal to the gm by r square. So from this del E equal to 5 by 6, capital gm place में capital gm equal to how much we can write? G into r square. So g into r square I written, remaining term m by r same. So 1r will be cancelled, remaining we will get 5 by 6 m g, 1r will be cancelled r. So 5 by 6 m g r. So 5 by 6 m g r. C is the right option. Like this you have to solve the problem. If you practice, you can do this problem also within 1 minute. Thank you.